So previously we discussed that if we would like to find the area between the two curves, we can use the integration of the difference between the two curves, f of x minus g of x, with respect to the x, where x changes from a to the b. So the basic idea of this integration was to split this area bounded by the two curves into as many small rectangles, and by summing the areas to find the area enclosed by these two curves, right? So in this example, in the following example, we will see that sometimes we need to make the vertical rectangles, and sometimes we need to use the horizontal rectangles. But the conceptual idea of this will be the same. So divide this area into the many rectangles, and by summing the areas of the rectangles, find the total area. So the example will be like this. So we're given two curves, y is equal to the x minus 1, and the second curve will be y squared is equal to the 2x plus 6. And we need to figure out the area enclosed by this by these two curves. So in order to find this area, let's first of all draw these two curves. So the first curve seems to be a line, right? So y is equal to x minus 1. And in order to find the curve of the line, we just need to find the 2 points on this line, right? So y is equal to x minus 1. So I find the first point by giving the x to be equal to 0. The y coordinate of this point will be equal to minus 1, right? So the first point will be here, was the coordinate 0 and minus 1. And the second point, I will give the y to be equal to 0. And if I give the y to be equal to 0 to this equation, it gives me x is equal to 1. So the second point will have the coordinates 1 and 0. And by connecting these 2 points, or by making the line which passes through these 2 points, I can find the graph of this line. So while the second one seems to me the parabola, where the x and y are just changed, right? So I just need to draw this parabola which is lied on the x line. Okay, so let me first of all try to find the x from here. So x will be equal to the y squared over 2 minus 3, right? So if I would like to find the most left point, I just need to find the critical points here, right? But now, in order to, instead of taking the derivative with respect to the x and equalizing this to the 0, we'll take the derivative with respect to the y and equalize this to the 0. So let me take the derivative of the x with respect to the y. So this will be equal to the 2y over 2 minus 3. By equalizing this to the 0, we can figure out that the y is equal to the 0. So the y coordinate of the critical point is equal to the 0, and the x coordinate will be equal to minus 3. Right? So the most left point will be here, minus 3, and this curve will look like roughly like this, right? So first of all, we'll try to figure out this area enclosed by these 2 curves by making the vertical rectangles. So in order to do this, first of all, we need to define the above curves and the below curves, right? So obviously, I can split this parabola into the 2 curves. The above curve will have the function in the form y is equal to the square root of tx plus 6, and the below one will have the different equation, will be minus square root of tx plus 6. Okay, so you see, so in this region, when the x changes from here until here, the below function is like 2 different functions, right? So that is why we need to find the area until this point, until here, and here separately. So we'll find the area A1 first, then we'll find the area A2, right? But for both of these cases, I need to figure out the coordinates of this intersection points. So we call the points at the intersection points, or we call the when the 2 curves are intersecting in this point, right? So mathematically, it means that we need to figure out the pairs x and y, so that this pair will satisfy the equation of the both curves, right? So basically, we need to solve the system of equations. So y is equal to the x minus 1, and y squared is equal to the tx plus 6. So we need to figure out all possible pairs of the x and y which would satisfy both of the equations. So this is the conceptual meaning of the intersection point, right? So we call the point as the intersection point if it is lying on both of the lines at the same time, right? So in order to solve this system, we will just substitute the y with the x minus 1 in the second equation. So this will be equal to the x minus 1 in the square is equal to the tx plus 6. So if I open up all the brackets in the left and put everything to the left, we'll get x squared minus tx plus 1 minus tx minus 6, which is equal to the 0. So if I simplify this expression, I will get this equation, and if I regroup the terms, I can write this as x minus 1 minus 5 multiplied as x plus 1 is equal to the 0, right? So the x coordinates of the intersection points will be equal to minus 1 and 5, right? In order to find the y coordinates of the intersection points, we need to put the x to one of these equations, right? Both of the equations obviously gives you the same y, right? If you put the x to be equal to the minus 1 to the first equation, it gives us minus 2. If you put this to the second equation, minus 1, it gives you the same, like a plus minus 2, right? And we'll choose the minus 2. Okay, now in order to find the y coordinate of the intersection point here, so we need to substitute the x to be equal to the 5 to the first equation, and it gives us the 4, right? So this pair gives us the coordinates of the first intersection point. It will be minus 1 and minus 2. And the second pair of the numbers gives us the coordinates of the second intersection point. So here, the coordinates of this point is equal to the 4, 5, and 4. 5 and 4, right? So basically, if I would like to find the area A1, we need to integrate the difference between the blue curve and the red curve when the x changes from minus 3 and until minus 1. And in order to find the A2 area, we need to integrate the difference between the blue curve and the black curve where x changes from minus 1 until 5. Okay, so let us find each area separately. So the area A1 will be equal to the integration of the difference between the blue curve and the red curve, right? So the equation of the blue curve is equal to the plus square root of t plus tx plus 6, and the equation of the red curve is minus square root of tx plus 6. So this will be square root of tx plus 6 minus square root of tx plus 6. So we need to integrate this with respect to the x, where x changes from minus 3 until minus 1. Okay, so since this one is the same, and if I sum them, I will get the 2, right? So this will be 2 integration of the minus 3 and minus 1 of the square root of tx plus 6 dx, right? In order to integrate this, we need to figure out the antiderivative of this. So let's discuss this separately in a moment. So antiderivative of the square root of tx plus 6, it appears, is equal to tx plus 6 in the power of 3 over t divided to the 3 over t multiplied to the 1 over t. Right? So I put here this minus 1 over t because of this t here, right? So the idea is here, if I take the derivative from this one, it will be equal to the tx plus 6 in the power of 3 over t minus 1, right? Then this 3 over t goes to here, and it will be cancelled with this 3 over t. And I have to additionally multiply this to the derivative of the tx plus 6, which is equal to the t, which will be cancelled with this t, and I will have exactly this function, right? So if I simplify a little bit here, I will get, so 1 over 3 multiplied to the tx plus 6 and the power is 3 over t. So this 3 over t means I need to take the square root of tx plus 6, then find its cubic power. Okay, so let me continue evaluating this integration. So it will be equal to the 2 multiplied to the 1 over 3, right, multiplied to the tx plus 6 and the power is 3 over t. And I have to evaluate this from minus 1, from minus 3 to the minus 1. Okay, so let me put the minus 1 instead of the x. It will be t over 3 multiplied to the t multiplied to the minus 1, which is equal to the minus t plus 6, which is equal to the 4 in the power 3 over t, right? Minus, I have to now substitute the x was the minus 3. It will be t over 3 multiplied to the minus 6 plus 6 in the power of 3 over t. Obviously, the second term is equal to the 0. And the first term will be equal to, so 4 in the power of 3 over t means basically I need to take the square root of 4 and find its cubic power, right? Because 1 over t here means the square root of 4, right? So which is equal to the t in the cube, which is 8, multiplied to the t over 3 gives me 16 over 3. Okay, now let's discuss how to find the area A2. So in order to find the area A2 on this graph, what we need to do is we need to integrate the difference of the blue curve and the black curve when the x changes from minus 1 to the 5 now, right? So this will be a difference between the blue curve, which is square root of tx plus 6, minus the black curve, which is x minus 1. And we have to integrate this from minus 1 until 5. Dx, right? So we know the antiderivative of this one is equal to the 1 over 3 multiplied to the tx plus 6 in the cube over 2 minus x squared over t is the antiderivative of the x, and the minus was the minus 1 becomes plus 1, it will be plus x. So we need to evaluate this antiderivative at the minus 1 and plus 5. So let me put 5 instead of the x's. So if I put the 5 to the first x here, I will get 5 multiplied to the t, which is 10, plus 6, which is 16, right? So this will be 1 over 3 multiplied to the 16 in the power of 3 over t, minus 25 over t plus 5, right? Then I have to subtract this when I from the value when I will calculate this for the x is equal to the minus 1. So if I put the minus 1 to the first one, I will get 1 over 3 multiplied to the minus 1. It will be 4 and the power of 3 over t minus 1 in the square is equal to the 1 over t. It will be 1 over t minus 1. Right? Now let me open up all the brackets. So if I evaluate this here, so this is equal to the square root of 16, which is 4, in the cube, which is 64 over 3, minus 25 over t plus 6, right? Minus, here I have to find the square root of 4, which is 2 in the power of 3, it will be 8 over 3. With this minus, it becomes plus 1 over 2, right? Plus 1 over 2. And with this minus 1, it becomes like a plus 1, right? Plus 1 over 2 plus 1. Okay, so let me simplify everything. It will be equal to the 56 over 3. So the minus 25 over t plus 1 over t, it gives me minus 24 over t, which is minus 12. And this 5 was this 1 will give me plus 6, right? So the answer will be equal to the 56 over 3 minus 6. So still the total area, we didn't find the total area. The total area will be equal to the sum of the A1 to the A2. So the area of the A1 was equal to the 16 over 3. Then the area of the A2 is equal to the 56 over 3 minus 6. Right? So if I sum this one to this one, I will get 70t over 3 minus 6. So 70t over 3, which is equal to the 24 minus 6 gives me 18. Okay, so the area between these two curves is equal to the 18, it appears. But we could solve this problem easier by making the horizontal rectangles. So let's discuss this idea, this concept. So let me draw the curves again, the same curves. So first of all, we need to draw the line, right? So the line passes through the points with the coordinates 0 and minus 1 and 1 and 0. then I have to draw this parabola, kind of parabola, right? Like this and like this. So here x is equal to the x line and y line. Now the idea would be to divide this to the many horizontal rectangles, right? So I know that the y here is equal to the minus 2 and the y here is equal to the 4, right? So this interval between minus 2 and 4 in the y-axis, I'm going to split this to the many rectangles. So let me draw one rectangle here and trying to figure out what is the area, what would be the area of this rectangle, right? So since I'm splitting this area, this interval between minus 2 and 4 in the y-axis to the many small rectangles, the height of this small rectangle would be equal to the dy. So actually dy is equal to the 4 minus 2 divided to the n, right? So dividing this interval between minus 2 and 4 into the n small pieces, where the width of each of the pieces will be equal to the delta y. Now the width of this rectangle will be here. Now the difference between the x coordinates. So previously we could find the height of the rectangles by finding the difference of the y coordinates. Now we can find the width of this rectangle by finding the difference of the x coordinates, right? So in order to find the x coordinates, we need to express the curves using the x, right? So the first curve was equal to the y is equal to the x minus 1. If I find the x from here, it will be equal to the y plus 1, right? So if I'm given some point y0 here, the x coordinate of this point will be equal to the y0 plus 1, right? So the coordinates of the first point would be equal to the y0 plus 1 and the y0, okay? So the second curve is equal to the y square is equal to the 2x plus 6. So if I find the x from here, it will be equal to the y square over 2 minus 3, right? And for a given y0, I can find the x coordinate by putting the y0 to here. So this will be y0 in the square over 2 minus 3 and the y0. So basically the width of this rectangle is equal to the difference of the y-x coordinates, right? The width will be equal to the difference of the x coordinates. So what we can do is, so the area of this specific rectangle will be equal to the y0 plus 1 minus y0 square over 3 minus 3 over 2 minus 3, right? And this is multiplied to the dy. Now, if I do this kind of rectangle, a lot of this kind of rectangles, and if I sum the areas, I will get this formula, right? So the summation of the y plus 1, yi plus 1 minus yi square over 2 minus 3 multiplied to the delta y in the limit will give me the integration of y plus 1 minus y square over 2 minus 3, right, dy, where the y changes now from minus 2 to the 4, okay? So the rest is simple technique. So the antiderivative of the y plus 1 will be equal to the y square over 2 plus y. Then the antiderivative of this one will be equal to the minus y cubed over 6 plus 4y, right? So let me simplify this first of all before evaluating this at the minus 2 and 4. So this will be equal to the minus y cubed over 6 plus y squared over 2 plus so here it would be 3y plus 4y, right? We need to evaluate this in the minus 2 and 4, okay? So let me put the 4 first of all. So if I put the 4, it will be equal to the 4 in a cube, which is minus 64 over 6 plus 4 in a square, it gives me 16 over 2 plus 16, right? Then we need to evaluate everything in the minus 2. So minus 2 in a cube is equal to the minus 8, was this minus gives me plus 8, right? So 8 over 6. Then I have to put the minus 2 to the second term, which gives me minus t in a square, which is equal to plus 4 over 2 minus 8, right? Let me open up all the brackets. So if I open up the brackets, I will get 64 was the minus over 6 plus 8 plus 16 minus 6 over 8 over 6 minus 2 plus 8, right? Or basically plus 6. So if I write everything down, so I will get 8 plus 16, which is 24, plus 8, which is 32, minus 2, which is 30, right? 30 minus, so here I will get minus 64 over 6 minus 8 over 6, which is equal to the minus 72 over 6, right, which is equal to the 12. So the answer will be equal to the 30 minus 12, which is equal to the 18. So we've got the same answer, but we could get the answer this was the second one way much easier, where the idea would be here to divide the area to many small horizontal rectangles.